Today is about completing the square. If you did not watch that video from last week, that was for extra credit. I'm going to show it today because it's going to be important for today's stuff. That's why extra credit is over, or that little piece is over after today. But here's why it's so important. We're going to use completing the square to write equations from one form to another, because I don't want you to have to memorize all these formulas for your test. And if I could rewrite equations from standard form to vertex form, because the vertex form spits out the vertex, then I wouldn't have to memorize that opposite of b over 2a, blah, blah, blah. So completing the square is a process that allows you to write something that's in this form as a perfect binomial squared. The trick is to divide b by 2, because you physically, so from that video, you physically take those x's and you divide them into 2. Some of them went by the x, some of them went below that x squared. That's what I mean, by the x squared or below the x squared. So we divide it into 2, and then we have to figure out, okay, how many units go into that little perfect square down at the bottom. So that's why if you have a highlighter, let's highlight. You need to divide that b by 2 and square it. We're just going to deal with, what if we're just given x squared plus 6x? Could we figure out how much would be needed to complete that square? So we won't worry about, okay, what's missing, what's all left over. We're just going to figure out what would complete that square. And then we're going to write the expression as the square of a binomial. 9 completes this square, but then let's write the expression as a square of a binomial. So this expression would become x plus, well, if I divided this into 2 to figure out the side length, it'd be x plus 3 squared. So take negative 12, divide it into 2 for 2 locations, and then look at the square. We get a positive 36, but then that perfect binomial square, the sides would be x minus 6. And then this is a perfect x plus 1 square. Step 1, move the constant to the other side. You just got to determine what's the constant. So let's write the left side as a completed square, x minus 3 squared. Because step 4 says simplify the right side, that's why I'm putting these into 2 steps. When we take the square root on both sides, I'm just going to make it x minus 3. And if you took the square root of 1, that's actually a plus or minus 1. So many times we forget that plus or minus, but let's not forget that this time. And then we solve for x. So add 3 to both sides. We get 3 plus or minus 1, but that's going to turn into 2 answers. 2 answers. We got to take 3 plus 1 and 3 minus 1. X squared plus 2x equals 8. So half of the middle term divided by 2, or sorry, middle term divided by 2 and squared. That's what we add to both sides. Then we write the left side as a completed square. This turns into x plus 1. Simplify that right side. And then take the square root on both sides. You cannot forget the plus or minus. When I take the square root of 9, it's plus or minus 3. Subtract 1 on both sides. And realize you get 2 answers. So we're going to add 9 to both sides. And then we take the square root on both sides. Subtract 3. And realize this turns into 2 answers. So move the 4x. Then complete the square. Divide that x term by 2 and square it. This is going to become an I. We're going to write the following equation into vertex form, but we're going to do that by completing the square. So we're going to complete the square of those terms. I should just circle these guys. We're going to complete the square of these, similar to that video. Figure out, okay, how much do I have left over, or maybe how much do I need? So completing the square, if I want to complete the square between x squared plus 8x, if I divide that middle term by 2 and then square it, I'm looking for 16. I'm looking for 16. So here's what happens. Typically when we're solving, we add 16 on one side, add 16 on the other side, but this 16 doesn't help us. So what we have to do is, what would happen if we moved it to the other side? It'd be a minus 16. So when I complete the square, I add the number and subtract the number on the same side. Because if you were to add it over here, that's not in vertex form. It doesn't help me to put it in vertex form. So let's see what happens. The first 3 terms, that's completing my square. We get y equals x plus 4 squared. Because if you look at, okay, what multiplies to 16, adds and gives you 8, 4 and 4. And now you can actually see where that minus 14 comes. I shouldn't put that in blue. Because we see the negative 16 and 2. What completes this square? Divide this by 2 and square it, you're at a 4. So negative 4 divided by 2 is negative 2, and then square it, we're at 4. But whatever we add in, we also have to realize on that same side we're subtracting. So the first 3 terms will complete our square. Here's where we see y equals x minus 2 squared. And then now we see the plus 6 at the end. Last one. So divide this by 2, we're at negative 1, and then square that, that's a positive 1. So to complete the square, it's positive 1. But then wait a second, I'd add 1 to both sides, but adding 1 to this side doesn't help me get into vertex form. So I just subtract it on the same side. These 3 terms complete the square. We get x minus 1 squared. And now we can see the minus 6 clearer.